Selection sort is one of the simplest sorting algorithms. That is why we are starting with it. The idea behind selection sort is simple. Split the input array into sorted and unsorted part. Find smallest number in unsorted part of array and swap it with the first element of unsorted part. Then we remove the first number of unsorted part and add it to the end of sorted part. We are going to use splitter, which is just index in array, to split the array to sorted and unsorted part. On the left side from splitter is sorted part, on the right side we have unsorted part. Splitter starts at 0 because we didn't sort any element, and it increases when you add number to sorted part. So when you add a number, the splitter moves behind the number that you just added. You can think of it this way. You can imagine that you have cards in right hand and you are trying to sort them so that you have them sorted in left hand, okay? You take the smallest card from right hand and move it to your left hand. Now you know that every card in your right hand is bigger than the card in your left hand. So you pick another smallest card from your right hand and put it behind the card you already have in your left hand. And you continue to do that until you have no more cards in your right hand. When you have no cards in your right hand, it means that in your left hand you have now sorted cards from the smallest to the biggest. I think you got the idea. Let's try it on our imaginary array. Okay, we have here an unsorted array and we shall sort it as a computer would. First of all, we are going to split the array into sorted and unsorted part. We are going to do that via splitter. Let's call him George. Now, we have to decide where to put George. Well, since we haven't sorted any number yet, we will put him at the beginning of array. So on the left side of George we have sorted part and on the right side we have unsorted part. Now we are going to find the smallest number in unsorted part. But computer is not a human. He cannot see that 1 is the smallest. So he have to compare every number in unsorted part and then he knows the smallest. And this is exactly what we are going to do. So we take the first number of unsorted part and compare it with every number behind it. If we find smaller number, we are going to mark that number as smallest. And once again we compare it to numbers behind. When we reach the end of unsorted part, we know that we have marked the smallest number. So we take 16 and compare it to 5. 5 is smaller, so we are going to mark that as smallest. And now we will compare 5 with numbers behind. We see that 5 is smaller than 11. That means we move on to next number. Now we compare 5 and 8, and once again we move on to next number. Now we compare 5 and 1 and see that 5 is bigger. So we mark 1 as smallest and continue towards the end. We compare 1 and 2. Obviously 1 is smaller, so we move on and compare 1 and 20. And once again 1 is smaller. And we reached the end. So we have found the smallest number in unsorted part. Now, as algorithm says, we are going to swap it with the first number. So now we have the smallest number at the beginning and we can move George by 1 number. And do it all over again. If you think that you understand it, try it yourself. Once again, we are trying to find smallest number in our unsorted part. So we take 5 and mark it as smallest and compare it to 11. 5 is smaller, so we move on to 8. Once again 5 is smaller, so we move on to 16. Now we compare 5 with 2. 2 is smaller, so we mark 2 as smallest and continue with numbers behind. In this case, we compare 2 with 20 and 2 is smaller. If there were any other numbers, we would continue, but there are not any. So we swap the smallest number, in this case 2, with the first number. Now, we have the smallest number at the beginning, so we move George by one number. I think you should get it now, so I'm going to do the rest a bit faster. Basically, what we do is we find the smallest number in unsorted part and add it to the end of sorted part. We compare 11 and 8. 8 is our new smallest number. Moving on to 16, where nothing happens. Now we compare 8 and 5. 5 is smallest. We compare 5 to numbers behind and see 5 is smallest. We swap it with first number and move George by one number. In the next iteration, we find out that 8 is the smallest number in unsorted part, but it is already first number in unsorted part. Well, that is just less work for us, because we don't have to swap anything, we just move George. In the next round, we find that 11 is smallest, and we swap it with 16 and move George. Even though this array is already sorted, computer doesn't know that. So he will go through one more iteration, compare 16 and 20, and add 16 to the end of sorted part. And once we have only one number, we know we are done. So this is our sorted array. Let's go and try to implement this thing. I prepared the new file. I called it selectionsort.js. You can call it however you want. And in here I just declared the new array. This A in front of the name stands for array. Okay, I keep track of the data type if you want. You can write it in there. You don't have to, it's up to you. So then I declared some array with some numbers, and I also look out the array so that we can see it. So right now when we go to view and then debug console, you can see the debug console. You may not see this thing in here, so then you need to go to debug and start without debugging. Like this. It will start the program, and in here you should be able to see this array, okay? So let's implement the selection sort. In here let's write a function. Let's call this one selection sort. Like this. And it will accept only one argument, right? It will be just some array, and I'll just call it input again. You can call it however you want, okay? But this argument is basically the array that we want to sort, okay? So right now we want to implement the selection sort that you learned in the explanation video before, right? You learned the idea. So the idea said when we implement some problem, the good thing to do is to break it down into sub-problems, right? Or when we implement algorithm, break it down into like sub-algorithm or like small parts of the algorithm. So what we did in the selection sort algorithm? Well, we found the smallest number, right? So that's a big part. So we need to find smallest number. Then we need to implement the swap, right? So we swap the smallest number with first number behind our wall. And then we need to loop through it, right? So there will be like outer loop. But let's in here first define the find smallest number part. So we expect that there will be something called wall, which will be just an index, and it will be, remember the wall from the explanation video, it will be just the same thing, only this time it will be just index, and it will point at first number. behind wall, okay? Behind the wall from like the explanation video, okay? So right now we can define the cycle. So we need to loop. I will just use for loop, and I'll create a new variable called j, and it will be equal to wall, right? Because we don't have to go through the whole array. All we need to do is go from the wall to the end of the array, okay? Hope that makes sense. So right now we need to check for the end of the array, right? So we loop while j is smaller than the length of array, and the length of array is just a input dot length, like this, okay? And we will increment j each time, like this. So that will kind of take care of the problem of going from the wall to the end. So right now when we index a input on index j in here somewhere, it will be just the element that we loop for, okay? Hope that makes sense. So right now what we need to do, well, we need to somehow keep track of the smallest number, right? Of the smallest element. So let's do that. We need to define a variable in front of the loop, because if it would be inside the loop, we would override it each time we iterate, okay? So we need to define it outside the loop, and inside the loop we can change the value. So let's call this one index of smallest. So this is just the index of smallest element. And in the beginning, we'll set it to wall. So remember in the explanation video when we set the first number behind our wall as a smallest, this is exactly, this is the line that does that, okay? So we set as a smallest the first number behind our wall, because this wall points at first number behind our wall, okay? And right now inside this wall, inside this for cycle, we need to check whether the element on index of smallest, so this element, so basically the currently smallest element, in the explanation video it was the blue element, okay, is whether it is bigger than the element that we currently are looking at. So that's the element on index j, okay? So that's the, I think it was yellow, right? Somehow yellow color. So the element that we currently compare it, okay? So right now, if the smallest number is bigger, we know that this is our smallest number. So how do we kind of change this value? Well, we know that inside this variable, we keep the index of smallest element. And we know that on index j is the new smallest element. So we simply change the value of index of smallest to j. Okay? So that basically, this is, remember in the explanation video when we change the color of some element to blue. This is exactly the line that does that. Okay? So right now, after this for cycle, we have the smallest element is on index of smallest. Okay, so in this variable, we have the index of smallest element. And all we need to do now is swap it with the first number behind our wall. And how do we know the index of first number behind our wall? Well, this wall variable that we have in here points at first number behind our wall, and we didn't change it inside the cycle, okay? So all we need to do now is set the number on wall index to the number that we have on index of smallest. Okay, but would it work? Well, we still need to swap it the other way, right? So we need to set the element on index of smallest to our wall. Okay, like this. Right? But would this work? Think it through. If we set the element on index wall to this, we override whatever is in here. So then when we set this side, we basically set it to this thing because we set the element on index wall in here. Okay, so imagine that this is 7, okay? So we set this element to 7, and then when we are setting this element is already 7, right? So we lost the information. So we need to take care of that problem. So we will define new variable, and we will store the information that we have in here, okay? So let's call this one temp as a temporary, and it will be equal to the value that we have as a first number behind our wall. Then we can override this value, and in here, instead of setting it to this, we will set it to the temp because that's the value that we want to set it to, right? So that's the swap, okay? And right now, all we need to do is loop through this all. So I will just define a cycle, and it will be, in here we will define the vol variable, and it will start at 0. Remember that in the beginning we put wall in front of the array, so that means in here, right? That means 0. And we loop while wall is smaller than a input dot length minus 1. Remember, as when I said in the explanation that when we have only one number in unsorted part, we are done. Well, that's this thing, okay? Minus 1 means that we are not looping. This loop stops before the last element, okay? So the last element will be the same. Hope that makes sense, okay? And in here we will just increment wall. And this wall incrementation basically means the movement of wall by one number. Remember when we add the element, we moved our wall by one number. That's it. This thing does that. So right now, we basically need to move this thing inside here. Okay, like this. I'll just tab it out so you can see it better. But right now we loop through the whole array. So this will take care of the do it all over again thing, okay? And another thing that we can do in here is set this j to wall plus 1. Why? Well, in here we compare the index of smallest to j, right? And if index of smallest is wall, there's no need to compare it to wall again, right? So we would compare the same elements. And why do that? We don't have to do that. So in here, the plus 1 will take care of that. We compare only the elements behind, okay? So yeah, let's hit save and let's try this thing out. So in here, I will just call selection sort with the a input, and then I will lock the input again, okay, like this. And if I run this using Ctrl and F5, you can also go to debug and start without debugging. As you can see in here, there is the array, but it is sorted, so this thing works. Right now, let me also check a few extreme cases. So when you test a algorithm, well, for first, this is not the right way to test algorithm, but if you're not a tester and you just want to know that it probably works, you need to take care of the most extreme inputs that you can get. And these will be, for example, that the first and last number is the smallest. So if I run this, there should be 1, 1, 1. There is 1, 1, 1. and the array is still sorted. And if I, for example, put in here like some big number at the beginning, let's see whether that works. And it should be like 1, 1, and last element is 100. This video is part of my Udemy course. If you are interested about it, make sure to go check it out. I'll leave a discount link in the description of this video.